Hi, these are some notes on our last lesson, integral as an accumulator. And I want to discuss three main ideas and then try some examples. The first idea when we deal with an accumulator is the basic main idea that when you take the integral of a rate function, it has to be a rate function, from some t1 time to t2, what you get out of that integral is the amount accumulated from time t1 to time t2. So the integral of a rate is equal to an amount. The integral of rate is amount. The second principle is, well, how do you know if a function is a rate function? And there's three ways you can tell. One important method is they will label it for you. They'll say the function is f prime, g prime, h prime, some sort of a prime, and then you know if it's a derivative function. Another way of saying it's a derivative function is to call it a rate function. So then if you integrate that rate function, you will get an amount. What's another way of knowing that you have a rate function? Well, when you read the paragraph problem, it'll say explicitly the rate h of x or the rate function f of x, and so then they'll just tell you flat out it's a rate. Or another way is that you look at the units of the function and then the units give it away. So you could have functions that are miles per hour or gallons per day, that would be a rate. People per minute, say like people entering a concert, people per minute. In general, when you have an amount divided by time, that's what makes it a rate. Now, the thing to know about this method here is that sometimes they'll give you the unit of a rate and then they don't have to call it prime anymore. So sometimes they'll say the function is f of t and it's in miles per hour. Well, they didn't say it was f prime, but by saying that it's miles per hour, they're letting you know it is a rate function. It's someone's derivative. Even if they don't put the prime on it, you should know this function is the derivative of another function because of the units. So very important to pay attention to the units. And again, if you integrate any of those rate functions, you will get the accumulated amount. And then the last point that we should keep in mind is the units of integration. What's happening as far as the units are concerned when you integrate something? Well, say here we have the function f of t. Notice that it's just labeled f of t. It's not a derivative. I don't see it as a derivative. But when I look at the units, gallons per minute, then that tells me this is a rate function. It is someone's derivative. It's just they chose not to use the prime label. But by giving you the units, you should know it's a rate. And here's the integral of that function from a to b, the integral of f with respect to time from a to b. And if you look at the units individually, the units of f of t would be gallons per minute. The units of dt, now dt is not shown, but we know that dt stands for a very small amount of time, or a very small change in time. So then what are the units of time? Minutes. And when you take change in time, if you subtract two different times, the units would still be in minutes. That's why the units of dt are minutes. And f of t dt means f of t times dt, but many times we just don't write the multiplication symbol. It's actually preferred not to have the multiplication symbol here, but you should understand that it means f of t times dt, and so then when you multiply the units, the minutes cancel out, you end up with gallons. And those gallons, when you think about it, isn't that an amount? It definitely is an amount. So you can see then that if you integrate the rate, just by doing dimensional analysis, by looking at the units, you get an amount, a number of gallons. You know something is an amount when it answers the question, how many? How many gallons? That makes it an amount. So again, just to recap, if you integrate a rate, you get an amount. You know something is a rate because it be labeled as a derivative, or because they tell you specifically it's a rate function, or mainly by looking at the units. Now it could also be a combination. They could call it f prime and then show you the units that are the rate function. They could say the rate h prime and then they're giving you two indications that it's a rate. But they could use either one of these. And always pay attention to the units of the integral. You take basically the y units and you multiply by the x units or the t units. And whatever you get out of that product, that's the units of the integral. And you can always check to see that that's an amount function. If it's a division, it's a rate. If it's just a solid unit and it answers the question how many, for instance, how many gallons are there, then that is an amount. So here's one example of an accumulation problem. It says your local theater is having a midnight screening of The Accumulator. Before the doors open, there are 430 people in the theater. This could be staff or people who are watching other movies. When the doors open for the special screening at 11 p.m., the rate of people coming into the theater is given by h of t equals to 0.3 t plus 2 people per minute. Simultaneously, the rate of people leaving the theater is given by g of t equals the square root of t plus t over 10 people per minute. T is between 0 and 90 inclusive. T is measured in minutes. And t equals 0 corresponds to 11 p.m., which is when the doors open for the special screening. And the first question, write an expression for P of t, the total number of people in the theater at time t. When you talk about accumulator type problems, this is always going to happen. They're going to give you an initial amount. In this case, amount refers to the number of people. The initial number of people in the theater, 430 of them. They're also going to give you the rate of gain, which is the rate of people coming in, and that was 0.3t plus 2. Notice they did not label it h prime, but we know it's a derivative because of the units, people per minute. So this is a rate function, h of t. And they're also always going to give you a rate of loss, how many people are leaving the theater. That's given by g of t. Also, they did not call it g prime, but it's a rate because the units, people per minute. So then to answer the first question, an expression for the total number of people in the theater at time t, we're going to say that first you have to recognize that they're asking for an amount, the total number of people. It answers the question, how many? How many people are in the theater? Well, that's what this function is going to give you. So then we should start by saying P of t is going to equal, and let me just give you the template for how all types of questions like this will be answered. It's always going to be the initial amount, I'm going to abbreviate amount, plus the integral of the rate of intake, how much you are gaining, and then minus the integral of the rate of loss. Loss, that's how you spell loss. how many people are exiting the theater. But it's always those three components. What do you have initially? How much are you adding to it? And how much are you losing? So then notice that the initial amount does not require an integral because this is already an amount. But here you require an integral because you're integrating a rate to get an amount. And here, same story. You integrate a rate to get the amount of loss. Now you can go back and apply it to this particular problem and say P of t is going to equal the 430 people that were already in the theater plus the integral. Now let's think about the limits. The question says write an expression for P of t, the total number of people in the theater at time t. So even though we're looking at it for 90 minutes, from 0 to 90, they said they want the expression at any time t. So that means that the integral is going to go from 0, which is 11 p.m. when the doors open, to t, any time between the first 90 minutes after the doors open. Now, because they labeled their function h of t, if you wanted to, here you could just use the label h of t. But I'm just going to go ahead and write out the function 0.3t plus 2. But then the other thing I have to keep in mind is my integral is from 0 to t, so I cannot use t's again in my integrand. I have to use the dummy variable or the standby variable. So this is going to be the integral from 0 to t of 0.3 x plus 2 dx. And again, the reason I'm using x's is to not use the variable t again. Now, if I were to do this by hand and integrate it and then evaluate from 0 to t, at the end my function does become a function of t. Okay? And now minus the integral from 0 to t of the rate of loss, which is my g of t function. Again, I could just call it I should call it g of x dx, but I'm just going to write it out and say it's the square root of x, replace t with x, plus x over 10 dx. And this is my expression for P of t. Now, this formula never changes. Those three items are always going to be there. The initial amount, the integral of the rate of gain, your intake, and the integral, take away the integral of your rate of loss, or the amount that you're losing. And then the only thing that changes is the storyline. This could be people coming into a theater, it could be mosquitoes flying in to a house, it could be anything really. But you have a specific initial amount, then you have more amount coming in, and then you have some amount leaving a container, and then those are the three elements. When you look through the AP packet, I think you had homework on this, right? It wasn't a quiz, it was homework. I think it was homework. When you look at your AP packet, try to identify the three pieces: initial amount, rate of intake, rate of loss, and see how it just gets old after a while because it's always the same three things. You just have to know to put them all in a function and then be able to answer the questions that follow. And so we have the answer to part A. I'm going to keep my answer from part A because I think that's a very important equation, the equation that gives you the amount. Now part B, how many people left the theater from 11 p.m. to midnight? So they're looking for an amount. How do I know they're looking for an amount? Because the question is how many? And they only want the amount that I've lost. How many people left the theater? So then I don't need the gain, and I don't need the initial amount. I just want to know how many people left the theater. So all I have to do then is take the integral of the loss, which is the square root of t plus t over 10 dt. And what are my limits going to be? Well, it says from 11 p.m. to midnight. 11 p.m. was when the doors open, and they told me that that corresponds to t equals 0. And midnight would be an hour later, but let's be careful, don't put from 0 to 1. Time is measured in minutes, they said, so then it's from 0 to 60 minutes later. So the integral from 0 to 60 of the square root of t plus t over 10, which is my rate of loss. When I integrate a rate of loss, I will get the amount lost, and because it's from 0 to 60, that happens from 11 p.m. to midnight. This would equal, let's see, t to the half. So if I integrate t to the half, it's t to the 3 halves times 2/3, and then plus, if you integrate 1/10 of t, you would get t to the second, and then you would divide by 2, but there's already a 10 in the denominator, so it's 1/20th t to the second, and then we evaluate from 0 to 60. And I don't think they want me to do this by hand, because then 60 is a big number, then I have to square it, cube it, so I'm just going to go to the calculator, and it tells me that I get 489.839 if I round to 3 decimal places. However, these are people. You can't have 489.839 people. And so then usually we round up and we say that's 490. Now on the AP test, they'll tell you how they want you to round that. They'll say to the nearest person, I guess. So this is 490. Now you have to use units because this is an accumulation problem. There's a story behind the math. And so if you just go with 490, there's a good chance you will not earn a point because of units. Sometimes they remind you on the question, it'll say use appropriate units, but they don't have to remind you on the question, and so you have to be aware of this. 490 people, and so that would be the answer to this. Now you should always check for the reasonableness of your solution. In the context of the story, is that something you would expect, 490 people? Well, we had originally 430 people in the theater, so how is it that more people than 430 left the theater in the first hour? Well, it could be that some of these people were in other theaters watching other movies that started before the 11 p.m. screening, and it could be that some of the staff members left early, or they finished their shift at work. And so I would say that this sounds like a plausible answer for 190. And I'm okay with the math. I think the limits are right. This makes sense to me. And I feel okay about this answer. It could also be that some of the people who showed up for the 11 o'clock movie just realized they left something at home, went back. Or some people sat through the first few minutes and then didn't like what they saw, and then they went back home. So again, I think it's a plausible number. Now, if you would have gotten a negative answer to this, then something's wrong. If you, for instance, have like 1,000 people left, and something's fishy about that. But this sounds like a reasonable amount. Next question, is the number of people in the theater increasing or decreasing at 11:40? Well, first I would like to know what time is that, what value is it for my t variable? Remember, t equals 0 represents 11 p.m. T is measured in minutes, so 11:40 would be t equal to 40 minutes after 11. And so then how do I know if the number of people in the theater is increasing or decreasing? One thing to not do, and one very common mistake, is students say, well, let's take a look at what's happening right before the 40-minute mark, and then let's take a look at what's happening right after the 40-minute mark, and then let's compare the two numbers. So some people, they use, let's say, 39. They plug it in here, because remember, this equation gives you the number of people in the theater, right? So they'll put 39 here, and then they get a number, and that's how many people are in the theater at 39 minutes. Then they put 41, and that tells them how many people are in the theater at 41 minutes. And then they compare the two numbers, and they say, if I had more later, then the number of people increased, and if I had less later, then the number of people decreased. But that's not the way to go about it, because from 39 minutes to 40 minutes, a lot of things can happen. And between 40 minutes and 41 minutes, many things can happen. So that's not a good indicator of if the number of people, whether the number of people is increasing or decreasing. The thing to do is to recall what we've done in the past. When a question mentions increasing or decreasing, that is a derivative. A derivative of what? Well, they want to know if the number of people is increasing or decreasing. So then we're looking for the derivative of the number of people. And if P of t is the number of people, then the derivative of the number of people would be P prime of t. So that's what we need to find, P prime of t. And then once we have it, then we'll plug in t equal to 40. Okay, so let's just take the derivative of the blue expression here, and that would be P prime of t. The derivative of 430 is equal to 0. The derivative of the integral 0.3x plus 2, how do we write that? Let me actually write it all out. 0 for 430 plus the derivative with respect to time of the integral from 0 to t of 0.3x plus 2 dx, and then minus the derivative with respect to time of the integral from 0 to t of the square root of x plus x over 10 with respect to x. This is just a very long way of saying I want the derivative of those pieces, and of course the derivative of 430 is equal to 0. But what does this remind you of? The derivative of the integral. This is the fundamental theorem. So let me write the simplified form. The derivative with respect to time of the antiderivative of 0.3x plus 2. I hope you recall that that is 0.3t plus 2. So it's exactly the integrand that we had before, and all we have to do is we have to do a substitution for the variables after you take the fundamental theorem. And then for the other piece, it'll be minus, but I should open parentheses. Maybe I should have parentheses here as well. Minus the derivative of the antiderivative, that would be the square root of t plus t over 10. And there's P prime of t. Very simple to take if you know the fundamental theorem. The derivative of the antiderivative is just the integrand, but then you have to make the substitution for your variables. So then at the end you can see that it is a function of time, P prime of t, and that's the variable you see at the end, the t variable. Now, now we have to plug in a 40 on this. So then I try P prime of 40. By the way, if this is a calculator problem, you don't even have to show this here. This is just me letting you know in the video how I'm getting my values. But this line here, you don't have to show it. You do have to show P prime of t, and then P prime of 40, you can go right ahead and just plug in the number and write down your answer. I got 3.675. Please do check my work. You should try this on your own and see if our numbers match. And so what does this mean, 3.675? The question was, is the number of people in the theater increasing or decreasing at 11:40 p.m.? And now I have this number, 3.675. So let's make sense of it all. P of t is the number of people. P prime of t is the rate of that number of people. And we said increasing and decreasing means the derivative of whatever is increasing or decreasing. So if the rate is positive, forget the 3.675, it's a positive number. If the rate is positive, what does that tell you about the amount? Got it? If the rate is positive, the amount is increasing. So all you have to say is now, this is greater than 0, and I would say something like, therefore, the number of people in the theater is increasing at t equals 40. Or I shouldn't say at t equals 40, I should say at 11:40, because that was the way they phrased the question. At 11:40 p.m. Okay? And this is not a new lesson, we've done this before when we talked about increasing or decreasing functions. So if the rate is positive, the amount is increasing. If the rate is negative, the amount is decreasing. That's how you would answer that question. Okay, so I moved a few things around to fit my next question in. Find the maximum number of people in the theater on 0 less than or equal to t less than or equal to 90. They're going to keep on asking this question. Optimization is a big thing. Finding the maxima or minima, very important question. So how do we do this? Find the maximum number of people. This is just like before. Anytime you're optimizing something, the first thing you want to know is what's the primary equation? And primary equation is whatever you want to maximize or minimize. And in this case, it's the number of people. And don't we have an equation for that? Yes, we called it P of t. That's the primary equation. And then what do we do to this primary equation? We take P prime of t and we set it equal to 0. So that's what we're going to do then. There's P of t. We had the derivative with us a little while ago and I erased it. But let's go ahead and write it in again. P prime of t. It's going to be 0 for the 430. And then here, the fundamental theorem, it's going to make it 0.3, but then the x becomes t plus 2. And I should probably have that in parentheses and then minus. And that's going to be square root of t plus t over 10, again because of the fundamental theorem. And there's p prime. That's a decimal here. 0.3 t plus 2. And what do we do with the primary? Oh, set it equal to 0. Okay. So let me go to the calculator and try to figure this out. Well, my calculator says that it cannot find the 0. I graphed this function. I changed the window so that it would show from 0 to 90 minutes. And the graph never crossed the x-axis on 0 to 90 minutes. And so then I guess we're going to say P prime of t. Let me just fix this real quick. P prime of t does not equal 0. What does that mean? That means you have no critical values. So there's no relative max, no relative min, no critical values. So how am I going to figure out the maximum of the number of people? Well, it has to happen at the endpoints. So now we evaluate, which is what we would have done anyway. Even if we do find critical values, the next step is to evaluate. Evaluate endpoints. Now again, when you try your homework, if you find critical values, you also bring them in, and you evaluate endpoints and critical values. And where do we evaluate the endpoints? It's always going back to the primary equation, P of t. So that means we are going to find P of 0, and we're also looking for P of 90. And the larger number would be the maximum, and the least one is the minimum. So let's find P of 0. What do we do for P of 0? It's just a substitution now. There's P of t, that equation. So let t be 0. Now remember, only t becomes 0. So we have 430 plus the integral from 0 to 0 of 0.3. Now this x does not become 0. The x is not a t value, it's just x. So 0.3x plus 2 dx. That's actually one of the reasons that we have it as a standby variable, so that we understand that only t becomes a 0. Minus the integral from 0 to 0 again of the square root of x plus x over 10 dx. And what does all that equal? Well, this integral, 0 to 0, that's going to go to 0. 0 to 0, that's going to go to 0, because there's no room to accumulate any area. And so we do have a 430 at the beginning, which was the initial amount. Now that makes perfect sense. This is the number of people at 11 p.m. when the gates were about to open. The number of people in the theater is just exactly 430, which is what you initially had. P of 90, then that would be 430 plus the integral from 0 to 90 of 0.3x plus 2 dx, and then take away the rate of the loss from 0 to 90 of the square root of x, that's 90, not 96, plus x over 10 dx. And I'm going to go to the calculator and figure this out. Okay, so my calculator says that I get 850.790, but that should round up to 851 people, and I should use units every time I'm answering questions here. And so now, again, no critical values, just the two endpoints. If you had found some critical values here, then of course you evaluate those and you compare the results. So then I'm ready for my final answer. Let me just read the question one last time. Find the maximum number of people. The maximum number of people. So then the answer is the maximum having problems with my pen. The maximum number of people in the theater is 851. And if you want to, it's always a good bet to include the time when this happens, and it's at t equals 90. You can say at t equals 90, or you can say when that corresponds as far as the time. T equals 90 is an hour and 30 minutes after 11 p.m. So it would be at 12:30 a.m. You can say at 12:30 a.m. or you can just say at t equals 90 minutes. Always use units for the time and for the amount. And I think this pretty much covers the type of questions you would see on the AP packet for the homework. If I can think of anything else, I'll have another video on it. I think I just want to now work on a video for differential equations. Several of you did not make it to our second Blitz session that took half a day, and we did a lot of work on something called differential equations and slope fields, and those topics, they are going to be on the AP test. And if it's a free response, you can get easily 6 of the 9 points if you know how to take care of differential equations. So I think my next video is going to just concentrate on differential equations. If you did go to the Blitz, I still recommend you watch the video and review how to solve the differential equations. Okay, see ya.